you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, Mr. T here with a tutorial on solving rational equations. I apologize today for my voice. I've got a cold or allergies or something. I hope you can understand me. A rational equation is any equation that has at least one term that has an x in the denominator. So you'll see a fraction that has an x in the denominator. Our procedures for solving these, we're going to divide them into two different categories. One category of problems is the proportion problems. They will be identified by having a fraction equals a fraction, so only a single fraction on each side of the equation and nothing else. And these will solve just like proportion problems we did in basic math, and we do that by cross multiplying. All the other problems will have on one side of the equation either multiple fractions or multiple terms, and those, our basic technique will be to identify the least common denominator of all the denominators all the way across the equation, and we're going to then multiply every term on both sides of the equation by that LCD, and the effect will be that all the denominators will cancel out when we simplify. So in both of these procedures, either by cross multiplying or by multiplying by the LCD, we result into a linear or polynomial equation with no fractions. And these we've already spent a lot of time learning how to solve. One issue that we need to be aware of when solving rational equations is that we can come up with extraneous answers. We've had extraneous answers in other types of problems we've worked recently, radical equations, logarithmic equations, etc. So to identify extraneous answers, we have to check each answer that we find, each possible answer, and put it back into the original equation, and what we're looking for is, will it cause a divide by zero? If so, it's extraneous and we'll throw it out. So let's look at some examples. Our first example here, we have fraction equals fraction, so it's a proportion type. So our procedure is to cross multiply. So we're going to take the numerator on the left side times the denominator on the right, and we'll write that on one side of our equation. We can bring down our equal sign, and now we're going to multiply on the other diagonal, and so now we have 3x times x plus 3. So notice now we don't have, there are no fractions, so now it's just a simple polynomial equation, so we're going to distribute on both sides. And we see we have x squared, so we have a quadratic equation. If you remember, on quadratic equations, we want to make our equation equal to 0. So I'm going to subtract this 2x squared. And we're going to add 6x. So we're doing the opposite operations. So that gives us 0 equals x squared plus 15x. And remember, our key technique on solving quadratic equations is to factor and use the zero product property and set each factor equal to 0 and solve. So on this side, we've got both terms have x's, so we can use our GCF factoring to factor out an x. And now we set each of these terms separately to 0, and we get x equals 0, and we get x equals negative 15. Now if we go back to the original problem, if I put 0 into this denominator, I don't get 0, and I don't get 0 here, so this solution is a good solution. And if I put negative 15 either here or here, again, I don't get a 0, so that's a good solution. So this particular problem had two solutions. All right, let's look at another one. So let's do the same thing here. Fraction equals fraction, so when we cross multiply, we get what I'm writing here. And we're going to distribute on both sides. And again, we have a quadratic equation, so we're going to set it equal to 0. And there's nothing to combine the 6x with, so let me just put it over here for now. Now we'll put this in standard order, so we've got 3x squared plus 6x minus 45 equals 0. Now we want to factor. We can simplify this. We can notice that all the coefficients are divisible by 3, so to make the factoring easier, I'm going to divide out by 3 all the way across. And now we've got x squared plus 2x minus 15 equals 0. So in this type of trinomial factoring, we're looking for a pair of numbers that multiply to be negative 15 and add to be 2. So that's going to be x plus 5 times x minus 3. And so we get possible solutions of negative 5 or 3. If we look at these into the original equation, this answer will cause both denominators to be 0. So this answer is extraneous. So we have a single answer, which is x equals negative 5. Now if we add some intelligence to our process, we can simplify some of these problems. Sometimes if we cross multiply, we can get some very complicated expressions. So if before we cross multiply, we try to simplify, we can make our lives easier. The times of simplification is we can look to simplify this fraction by canceling out any common fractions. On this problem, we don't have any. And we can look over here to see, are there any common fractions? So we are factors. So we would want to factor this denominator. So there's nothing we can cancel here. If there were, we would want to cancel those and use those simplified expressions. The next thing is we want to look at our two denominators. And if they both have a common denominator, we want to multiply both sides of the equation by that common factor. So that allows me here to cancel out this x minus 3 and x minus 3, and on this side we cancel. So now our simplified problem is 5 over 1 because we canceled out that entire denominator. And over here we're left with the x plus 3. Now we'll cross multiply. And now we have a linear equation, so we can get the x by itself. Divide by the negative 3. And we get negative 5 equals x. And we check to make sure back in the original problem that we don't get a divide by 0. So we get our answer. So with some intelligent simplifying, factoring and canceling common factors, or multiplying both sides by a common factor, our algebra that we were involved with here was simpler. Over here we had to have a quadratic equation and factor. In this case it was possible. Over here a linear equation. So keep that in mind when you're working these proportion problems. Now let's look at the other type of problem. On these, our procedures, we want to multiply by the least common denominator. So first we have to identify the least common denominator. So to do that, what we're looking for is what do we have to multiply to cancel each fraction out. So let's just start with the left. So to cancel this denominator, we need a factor of 3x. To cancel this denominator, we need a factor of 3. But we already have that, so I don't need to put another 3 in. To cancel this, we need a factor of x plus 6 in our LCD. We don't have an x plus 6 here, so I have to add it. So in factored form, this is our LCD. Now we're going to multiply each term of our original problem by this LCD. And since we've got fractions, I'm going to put it over 1. So we've got to multiply it times that term. We've got to multiply it times this second term. And we have to multiply it also by the other side of the equation. and we would be multiplying by this LCD even if one of these terms was not a fraction. Now we want to look at each of these multiplication problems and simplify. So here I can cancel out the 3x, and I'm left with 2 times x plus 6, so let's just go ahead and distribute that. Here I can cancel this 3 out with this 3, so I'm left with 2 times x plus 6. So we're going to be distributing, we'll multiply this monomial times this monomial first, so we get 2x, and then we're going to distribute. So I've got 2x squared plus 12x. Now if this had been a minus, make sure when you distribute that minus towards both terms. Now on the right side we can cancel out this x plus 6, so now we're left with 24x. So again, we ended up with a quadratic equation. So on this side of the equation we can combine like terms and put it in standard form. So we got 12x and 2x is 14x. Again, since it's a quadratic, we want to set it equal to 0. So I need to move this to the other side. This is 2x squared, sorry. And again, before you try factor, scan the coefficients. Since they're all divided by 2, we can make this be a simpler trinomial. So we've got x squared minus 5x plus 6. And now we factor this, and we can factor this. We need both factors to be negative, so two numbers that multiply to be 6 and add to be negative 5. That's going to be x minus 3 and x minus 2. And if we set each of those factors to 0, we get our possible solutions are 3 and 2. So if we go back to our original problem and plug them in, we can see whether or not either of these answers cause us to divide by 0. So in this case, if we put 3 in, we're okay. And if I put 2 in, we're okay. So we have two good solutions for this problem. All right, let's look at one more of these. So before we try to find the LCD, we want to factor any of the denominators. So we're going to factor this denominator using GCF factoring. So again, let's build our LCD by going across. So we'll start with the first denominator because we need everything in that denominator to cancel it out. Now when we go to this denominator, we need an x to cancel it out, but I already have the x here, so I don't need another one. And I need to cancel out the x minus 2, but I already have one, so this is my LCD. So again, we're going to multiply both sides of our equation, or actually not both sides, but all terms on both sides, by our LCD that we just determined. And we're going to simplify each multiplication problem. Now, if we've done this correctly, if you have the right LCD, every denominator needs to cancel out. If all the denominators don't cancel out, then you had not found the proper LCD. So here our x's cancel out and the x minus 2's. So here we're just left with 10. Here our x cancels, so we're left with 4 times x minus 2, so that's 4x minus 8. And over here, the x minus 2 cancels out, so we're left with 5x. So now we just have a linear equation, so let's get the x's on one side of the equation. So I'm going to subtract this 4x, and we get x equals 2. Now if we go back and plug that into the original problem, that's going to cause this denominator and that denominator to be 0. So this answer is extraneous. And since that was our only possible answer, this problem had no solution. Meaning there are no values of x. If we look at the entire real number system, there are no values of x that would make that equation true. All right, let's wrap up here with an application of rational functions. It's a chemistry example here, and let's assume we had a jar that had 0.2 of a liter of an acidic solution, and its concentration was 16 moles of acid per liter. And we need a diluted solution that has a concentration of 12 moles per liter. So we have to dilute this by adding water, and we need to figure out how much water should we add. So let's kind of create a model for this. So the way we determine the concentration of a solution is we know the number of moles of acid, whatever kind of acid we're using, so the number of moles of acid, and we divide that by our volume. On our new solution, our volume will be the volume of our original solution, so original volume plus the volume of the water that we add. And that's going to give us our new concentration. Now let's plug in some numbers. So we've got our new concentration we want to be 12 moles per liter. Now here we need to figure out how many moles of acid we had in our original solution. So our concentration was, our volume was 2 liters, or 0.2 liters. And so let's put it in our units so we can see here. And we multiply that by the concentration, which was 16 moles per liter. So our liters cancel out when we multiply here, so we get 0.2 times 16, or we had 3.2 moles of our acid in our original solution. Since we're adding water, we're not adding any more acid, so our moles will be 3.2. And now we need the volume, so our original volume was 0.2 liters. And we're trying to find out how much water to add, so let's call that X. So now we can see here we have a rational equation, and if we put this over 1, we have our proportion type of problem, so we can cross multiply. So we get 3.2 equals, and here we're going to multiply 12 times that. So 0.2 times 12 is 2.4 plus 12x. Now we have a linear equation, so we solve that for x. So we get 0.8 equals 12x, and if we divide by 12, we get x being, let's see here, we get 0.066, so repeating, and those would be liters because our volume here was liters. So if we round that, that's approximately 67 milliliters of water that we need to add. And that's our solution. So lots of mixture type problems that we can work. We use rational functions and rational equations for solving those. So I hope with these skills you will find that working with equations with fractions, they're not going to be as scary or terrifying as maybe they've been in the past. And I hope these skills will also improve your number skills working with just regular number fractions, so that as you head into your college placement exam, you'll be able to perform better when you're working with fractions and not allowed to use a calculator. Have a great day.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you